Oh, I see. Okay, it's not that we don't have sound, it's that it's pointed the wrong way. Now we should have some sound. Okay. Now I think we're actually ready. What's this? So I am working on something a bit different than normal today, although one component is similar to what I normally work on and stream about. Today we are trying to interface Factorio, which is a video game, with this big controller industrial switch thing. So it's got kind of a go button, the green button up there. It's got a key which can go either right or left, one chunk, or it can sit in the middle. And then it has a red, like, sort of emergency stop button, and you have to twist it to get it to chunk back up. Kind of keeps itself in there till you chunk it back out. So I bought this thing a while ago, just off the internet, and my intention for it always was to try to use it to control stuff inside of Factorio, which is a video game about automation and making a factory, so it seemed pretty fitting. The first idea I have for it is to make it launch the rocket, which is kind of the final boss of the game in a way. Like, you can keep playing afterwards. It's a bit like the end dragon in Minecraft, right? Like, you get the cutscene that says you win the game after you launch it, but you can keep playing. That was kind of my first thought, was what if we made it to where this thing could launch the rocket? And I have kind of started researching how to do this in a few different ways, a few different times, and so far all the solutions I came up with were a little heavy on the Factorio modding side of things, which I don't have as much experience with, and it's also written in Lua, which I don't have a lot of experience with, and so I was finding it challenging to figure out how to do it. But I have come up with a way. Now is the time. I've got the proof of concept working, and so I want to flesh out the rest of the behavior that I'm interested in. Starting with the hardware, though, I'll kind of talk about all the different components real quick to just give you an overview of where it's at so far, and then start working on it, and you'll see kind of where we dive in with the stuff I want to do today. So inside of this, if I push this wire back through a bit, we have got Raspberry Pi Pico W. It is upside down there. You can kind of see it right in there. Raspberry Pi Pico W, and it's wired up with just ground to GPIO pins across all of these big chunky switches that are on the back sides of all the buttons there. So right now that's just running CircuitPython on that Pico W. I did just solder straight onto it. It's kind of the nice thing about this device, being a little $6 microcontroller. It's fairly cheap. It's not too big a deal to dedicate one to a project. I happen to buy a handful of them, so we got that one inside there. And so hardware-wise, that's what this is basically now just a CircuitPython device with 4 GPIOs wired up. One is on the green button, 2 are on the key, one for detecting turn to the right, one for detecting turn to the left. And then the 4th one is here, because it's 1, 2, 3, and then 4th is on the red button here. Detects when the red button is pushed down. So those are kind of the actions we have, and we'll build around those actions to make an interesting interaction, I think, with the game. Looking at some of the other components before I jump straight into working on it, I'll open up PyCharm here. And I'll open up Factorio. Let's have it in device workspace. So let's see, which side do we start from? I guess let's just start from the controller, since that's what I have talked about so far. So the way this controller is set up is with CircuitPython. All the switches are wired into it, and the way the code on it, what it does is read the switches, and then for some of them it just prints like what happened. So if we actually connected here to terminal, oh right, it's over here. Oh right, I was doing this whole side-by-side thing. Move that back for now. If we connect TO, and like I'm gonna press the, well, I'll do the key for instance. I can do key position A, which is turn to the right. I can turn it back to neutral, and I can go to the left, and so it's recognizing those. So right now, the red button and the key, all they do is print out. I just noticed we're in Chrome today instead of Firefox for the camera. That's all right. So these ones don't really do anything yet in terms of Factorio, but they are set up in the microcontroller to read the pins and print the states. So we're ready to like do whatever we want when those states happen, state changes happen. The green button is the one that is wired up as a proof of concept. And what it does is when you pressed it, instead of just printing, it's actually printing to a different place. It is printing to the secondary serial. CircuitPython devices can connect as two serials, so one of them is connected here. This one is the REPL, right? So I can go like Control-C in here, and now I'm in the REPL. I can run Python code, one line at a time on the microcontroller, right? This is running on the microcontroller inside of here, PicoW. I can get it back to the code, so get it to relaunch this code. So this one is writing to a serial port like this one, but it's secondary. It's not this one specifically. There is a secondary one called data, which is what this one is writing to. And so in my case, it is actually connecting as TTY ACM 1 for the data one, and then 0 is for the REPL serial console. So it's connecting there, and then when the green button is pressed, it is sending this message here, which CodePy shows it printing right there. So we write this message out, which is just kind of a primitive comma-separated string that represents a signal that we want to set inside of Factorio. What does that mean if you're not used to Factorio? If you don't know, we'll talk about what that is here in a minute. That's what this one is doing, and so if we, if I kind of show this and then maybe show like this over here, what we can see is like when I press the green button, it will send this message in here. Looks like it's sending it without the new line, which is interesting. I would have thought it got a new line on the end of it. Oh, no, because we're not writing a new line. Did I erase it? We should be probably writing a new line, I think. Or does write automatically add one? Yeah, that's weird. I don't know why. I feel like we should probably be sending that. Okay, I'll keep explaining here in a minute, but this, I think, is how we probably want this. So now this actually has a new line in it. Oh, but now we're getting this weird thing going on. Interesting. It's not quite right either, is it? All right, well, for now, let's just put it back. Okay, so far, we have the microcontroller, it's running CircuitPython, we're listening for the green button, we're sending this on the secondary serial port. Here I'm just looking at it get printed out, but in the context of actually using this, this is not what we want. We don't just want to print it here, so I'm going to close this thing. So that's no longer listening on that secondary serial port. We're going to go to downloads, we're going to go to Factorio, whoops. Go in here. We're gonna start the server. that is going to run the Factorio server on my computer. The headless server is now running inside this terminal here. I'm also now starting up the actual Factorio standard game client, and I'm going to go join the server that is running back here. So right there, we just joined the server that we're hosting back there inside of our game. So now we're inside Factorio. For the proof of concept, I have it set up to make a rocket, because remember I was saying, like, I like the idea of the green button launching the rocket. I'd like to do some more stuff with the key and the red button as well, but right now the proof of concept is set up with just making the rocket and using the green button. And so while that is building up, let's talk about the way that it actually comes in, right? So in our CircuitPython code, we saw that it's sending this string here. This is going to be getting interpreted by this other code, this serial signal interface. Serial signal interface. This is a Python script that is going to run on my PC, the same PC that's running the server, although theoretically you could do this across the network as well if it was running on a different computer, I think. What this does is it opens up the serial port. That's the serial port that's going back to that data serial line, that TTY ACM1 that we talked about before, where we saw this command coming through to. So this script is going to open that serial port, listen for those commands to come in. When those commands come in, it's going to parse what it means, and it's going to execute whatever it's supposed to do. So right now, the first command and only command at this point is this one. It starts with an S for set. Then it has an index, which is number. Then it has a, I think they call this a type. And these things are specific to Factorio, right? Like, we define these things to fit into the Factorio world. So we want to set a signal. The signal we want to set is at index 3. The type of signal is item. The name of the signal is rocket silo. And the value that we want to set that signal at is 1. So that's what this command essentially means. And on this side, it's reading the command and actually executing it. So it calls this set signal. Set signal is just abstracted into a function. Really what it does is take this big long command, which is this is a Factorio command. And what this command does is it manipulates the signals that are on this constant combinator. So right now, I just cleared out this constant combinator, right? So it doesn't have any signals on it anymore right now. Let's see here. We don't have anything in here, right? And our rocket is ready. We could take these out. Those don't matter, though. Our rocket is ready. We have this constant combinator. The way this works is when we get that command, we're going to set a signal on this constant combinator that aligns with whatever those arguments were passed in, right? We're going to set the one at this index. It's going to be this type. It's going to be this name. It's going to be this value. So in the case of this rocket one, if I split screen here, press the green button, anticlimatically, nothing happened. Let's take a look at green just released. Did it reboot? Green just released. Oh, I'm not running this, right? We were talking about this code. This code actually needs to be running. And then I guess one more link before I actually get in and do it. So we're sending this command to the Factorio server. The way that we are sending it is through this protocol called Archon, which is a more generic protocol. I think multiple games have this. I don't know if like every game, I'm sure every game does not have this. I don't know if it's like a Steam thing or it's just optional. You can introduce this if you want. Basically though, this is a connection that goes through the internet or network. And it allows you to send, generically speaking, send data, send text to the server. And that text can get executed as though it was a command. So inside Factorio, if you press the right button, which is, I don't know, there it is, okay, tilde. If you press this button, it opens up this box, and you know you can chat in here, right? Hello, and you say things. but you can also run commands, right? If you do -C, then that's running a command. I don't know one off the top of my head. Let's see if this works. See, this is the part, though, that I don't have that much experience with. I think game.player... What, player? Player.print? Print? I don't know if that's going to work. Okay, it did, yeah. So this one ran a command that printed differently, right? Like we printed the first time by just chatting. This time we actually executed a command. And there's commands that do all kinds of things, including manipulate signals on stuff. So this command manipulates the signals. We're sending it through Archon from this serial signal interface. We're sending that over to the Factorio server running back here. It's then going to execute whatever this command is, which is telling it to set the right stuff on this. So if we run this, run the interface, but now it's actually running. So now if I watch the constant combinator and press the green button, it put Rocket Silo, it put it in index 3, first of all, which if you're like me, you're like, no, it didn't. It put it in index 2. But no, it put it in index 3 because it starts counting at 1. Put it in index 3, and it put the type of signal is Rocket Silo. The count is 1. So this is kind of the core functionality that is going to enable this. This is the whole pipeline. The microcontroller in here reads the buttons, sends the serial message back to the computer, my PC, through USB. My PC is running this serial signal interface. It is watching for information, for data to come in on the serial port. When data comes in, it is going to turn around and send commands to Factorio using Archon. The commands, we fill in what we want it to do. So we'll have read signals and set signals. Right now I just have set in this particular code, although read signal is also working functionally. It's just not hooked up to a button right now. At least it was last I knew. Maybe it's broken now. We'll see. So that is kind of the core idea. And then before I jump straight in and start working on it, let's see it in action. So some more stuff that I have set up inside Factorio is, of course, I have some logic that is looking at the signals coming off of this combinator, the constant one. This is the one we're setting from our interface over here. We've got some deciders that are looking at the values coming off of that. The deciders are going into an AND operator, arithmetic, and then if all the right stuff is true, then this is going to output this fish signal, because I thought that would be amusing. And then this grabber arm has a condition that says only grab if the fish signal is greater than 0. So if this does not output fish, then this grabber arm won't grab. If this does output fish, then this grabber arm will grab. And so, yeah, we'll talk about the rest of the signals. They're like these things. We'll talk about what those do later because I'm going to dive more into that logic. But that is the basic flow, and let's see it actually work. So really what we're waiting on right now is auto launch with cargo. Once we put cargo into the silo, it will launch for us. And we know that when we press the green button, we'll get a rocket silo here. And that's the main thing we need right now in order to output the fish, which is going to let the arm move. So let's put satellite in this box here so that the grabby arm, so when the grabby arm activates, it's going to grab the satellite out of the box, put it in the rocket silo, and then we know that the grabby arm is going to activate when we apply that rocket silo signal here. It's going to go through all this stuff and it's going to cause the grabby arm to go. So oh, that's interesting. It doesn't match up right. There we go. So green button sets the thing, grabby arm goes, feeds in the satellite, rocket's firing up, shooting off its thrusters. There it goes. You can follow it for a while. Not too long because it's fast, because it's a rocket, but you could zoom in. I'm probably too slow though. So it's somewhere up there now, and it's gone. So there we are. This is kind of the overarching idea of what I'm trying to do, but I want to make it more interesting. I want to make the key and the stop switch do stuff, and I actually have kind of an idea of how I want this to work. And one of the things I want to do, because I also think it will be amusing, is make a instruction sheet or like data sheet type thing that describes how to use the controller inside the game. So like, let's see, what's a good way to, maybe we could just find one real quick. So, you know, like, it's just, I kind of searched up something like this. So like all kinds of stuff, right? Industrial equipment just has this kind of thing, right? Instruction sheets with which have a very recognizable document design, right? I think it would be kind of funny to make a fake one of these that is of this product, this rocket launching control switch product, and we'll write it up. I mean, I won't make it, you know, I'm not quite as dedicated enough to have however many pages this thing is, dozens and dozens and dozens of pages, but maybe we'll have a couple sections and we'll explain a few different parts of it, and then, you know, really the main thing I'm after is the cover page, because I think it's funny to make the cover page, and then maybe the secondary page, which is kind of fits into the design as well. And I have ideas already of how I'd like it to work, and so that'll make it actually easy to explain the code that I'm going to write to make it do that. So first thing, let's make this be the size of a piece of paper. It's A4, that's paper, right? Isn't that the plain paper? Well, if it's in landscape, maybe. Looks paper-like. Is A4 the default paper we use in the US? Oh, the next rocket is ready. I don't think the sound is probably piped through to come, but it's playing the alarm sound now. But it's the same deal. It won't go until its inventory is filled in. Its inventory won't be filled in until this grabby arm has a thing to grab and the signals are set. Although in this case, the signals are still currently set. We are still outputting fish, so it would still go. I've always heard 8.5 by 11. I didn't know it wasn't exact. Is it not exact? Easy to remember. A4. Huh, TIL. I had no idea. Is there a name for 8.5? Well, okay, the name is A4. We just call it 8.5 by 11. Why don't we just call it A4? I mean, I guess 8.5 by 11 is better because it's more descriptive, tells you more about it. So eventually I'm going to make the whole document here, but for now I'm just going to use this to be a place to kind of keep some of my thoughts and ideas. Where's text? I don't use this thing very much. There it is. So on the control switch, I want to have, I want to work in the red button and the key and stuff. And I think the idea, what I want to do is, I want it to be the green button only matters if the controller is armed, right? If the controller's armed, it has to be in the armed mode. Otherwise, the green button doesn't do anything. To get to the armed mode, you have to turn the key to the right. So key turns to the right, that puts the unit in armed mode. At that point, if you press the green button, then it will actually go. I'm going to start writing some of this out as well. Armed mode. Turn key to the right, enter armed mode. When you're in armed mode, I'm just going to do this as like maybe bullet points. Except I don't know how to bullet point. Bullet point. I guess if I just do this, will it bullet point? No, but that's good enough actually. Turn the key to the right to enter armed mode. If you turn the key back, then you leave armed mode. So with the key horizontal, you're in neutral mode. In neutral mode, the green button will not fire, right? The green button won't do anything if you're in neutral mode. So if turn key back to neutral, and then actually what I want it to do is actually if you leave the armed mode, I actually want you to go to the canceled mode. So if the key, let's see, if turn key back out of armed mode, then go to canceled mode. If green button press, and this is, again, if it's pressed while it's in armed mode, if you press the green button, then fire. If the red button is pressed, if red button pressed, then go to canceled mode. So we start out in neutral mode with the key horizontal. In order to arm, we turn it to the right. At that point, if we red button, we go to canceled mode. Or if we reset here and we say we're going back to armed mode, if we turn the key back out of armed mode, then we go to canceled mode. Once we are in canceled mode, if we want to get back to neutral mode, we need to release the red button. Get back to neutral mode, we want to release the red button. We want to also, with the red button released, you need to turn the key to the left and then turn the key back to neutral. And at that point, when you turn the key back to neutral from left, if the red button is not pressed, then you'll go back to neutral mode. So once you get to canceled mode, so like if we say we go to armed mode and then we red button, now we're in canceled mode. In order to get back to neutral from here, we have got to do two things, essentially. We've got to get the red button released, and we've got to get the key all the way back to the left, and then we've got to put the key back to neutral. And now we're back into neutral mode. Once we're in neutral mode, we could go to armed mode. Once we're in armed mode, we could press the green button to actually fire. So we have neutral mode. When you're in neutral mode, the key will always be horizontal. Yeah. When you're in neutral mode, the key will always be horizontal. Where's my key is horizontal. From neutral mode, you can either go to canceled mode, like if you're in neutral mode and you press the red button, then you're going to go to canceled mode. and then you have to do the same reset sequence to get back to neutral mode. Don't know how you spell canceled? Only one L, huh? Okay. That's definitely how you spell goto. I don't know what you're talking about. So red button will take you to canceled mode. Turning the key to the left would take you to canceled mode. Turning the key to the right go to armed mode. So this is kind of the rough logic I want. I think we covered all of the paths, but we'll see as we start making it. And so one choice I have is like where to put the logic that does this stuff. It could live inside the microcontroller. It could live inside of the signal interface. I think what I want to do is make it in the microcontroller, though. I want to keep track of these modes. I want to do all the enforcement of which mode you're in and which mode you're changing to. I think I want to do all of that in the CircuitPython code on the microcontroller and just have it simply send back these commands at the right time to set certain signals on that constant combinator inside the game. So let's do that bit, I think. It's roughly a state machine, right? Like we have these modes, and like when we're in certain modes, the behavior is this versus that. So let's say, should I keep calling them modes, or should I start calling them states? Canceled state, excuse me, armed state. Yeah, I guess we could call them states. Neutral. Armed. Canceled. Current state, we start on neutral. So now we basically just need to change the logic inside of here. So just start with what we had, right? Oof. Quite, we can just take that stuff for now and put it over here too. Okay, so let's just do neutral mode first. That's the mode we start in, so it kind of makes sense to code that one first. So when we're in neutral mode, the key is horizontal. We don't have to write any code for that. If the red button is pressed, then we go to canceled mode. So we have our red button pressed right here. So if current state, yeah, I guess we should probably change modes to states. Try to remember to say that. So if the current state is neutral and the red button has just been pressed, then current state changes to canceled. And I think what I would like is, I think I would like the thing to output M. Or I guess we should use S since we changed to state. I think I want to output S, and then the values will be like Just 0, 1, 2, or 1, 2, 3. I don't think it matters really, but so when we go to state canceled, we also want to write set index 1 virtual signal S. I don't know if that's going to be right. So let's say canceled is 1. We'll do neutral is 0, canceled is 1, and armed is 2. Should we make values for those or just remember it? Might be kind of nice to have values for the indexes as well to make the code more documenting. I don't know. Maybe it doesn't matter. I don't think the code's going to be that complex, really. So we should be able to go to canceled state, i.e. change the S signal to be 1 if we press the red button. Oh, but it's actually already down. Is it? It is. Oh, I heard it run, but it didn't actually update. Interesting. I'm guessing that this is probably not right. Would it be capital S, maybe? One thing I'm gonna do is put the screws in. I wanted to keep the screws out for a minute. Oh, I guess I don't have a screwdriver, though. Well, let me put 2. Hopefully that'll just keep it a little more stable. Ah, there we go. Okay. So now we have state equals 1, which is canceled. Let's clear that, and then what else? So from neutral, we also want to be able to go to armed. So when we are in neutral, if we turn the key to position A, then we want to go to state armed. We'll put it in the same index, so we're still going to write index 1, we're still going to write signal S. This time, though, we're going to write value 2. Value 2 is going to indicate that it's in state armed. We don't really need to do anything when the keys are released in most cases. So we should be able to go to armed. Turning the key. Nice. Okay. State 2 for armed. And then I guess for neutral, maybe I should use 1, 2, 3 instead of 0, 1, 2. Let's try 0, 1, 2. I feel like I'm going to get bitten by it, but we'll see. It won't be too hard to change. So really when this runs, initially it should set the state to 0. Oh. Oh, right. We want this, actually. There we go. So we saved that on the microcontroller. It reran. It wrote S0. Well, so I think the difference is that S0... Yeah, I think the difference is that S0 counts as, like, not existing or something. Is that... Let's use 1, 2, 3. I'm going to use 1, 2, 3. So 1 for... Oops. 1 for... neutral. 2 for canceled. 3 for armed. So 1 is neutral. 2 is canceled. We actually don't have a way to get back to neutral right now, so I'll just clear it. And then armed is... but we're not actually in neutral, right? We need to make the way to get back to neutral, I suppose. I could reset it, and that would get us back, but let's work on getting ourselves back. So when we're in canceled, in order to get back, we want... in this case, actually, we will use the released. We'll use the released of position B, which is the left turn of the key. So when you turn the key from left back to neutral, if the red button is also up, then we get to go back to neutral. So if current state is canceled, if red button debouncer dot, I think we can just do value. I'm not sure if, but it would be value false. No, true. Value true. If value is true, that means that it is not pressed because our buttons are pulling to ground when they press. If value is true and state is canceled, then we're going to go state is back to neutral. We are going to write our signal. Okay. We should be able to get back now. So we're in neutral to start, because our code just ran. Interestingly, though, the key is towards the right. Yeah, we should probably figure out, we should probably make something handle what happens if the microcontroller boots up and runs, but the key is not in neutral. We'll think about what we want. We are still in neutral now, though. If we go to canceled, so if we go left and then back, it's not going to work because the red button is still down. If I release the red button and then we go left, back, now it works and we get back to neutral. We go to the right, we go to armed. So while we are armed, so if it's neutral or armed, when the red button is pressed, then we're actually going to go to canceled either way. If it is armed, when the key gets turned... Honestly, it should just be if the key gets turned back to neutral, then it becomes canceled, I think. So if it is armed... and the key just got released, that means they turned it back from the right position. Go to canceled. That'll get us back from armed to canceled if we press the red button or if we turn the key back. Start out in neutral. Yeah, we will have to figure out what to do about that. Should we just... I mean, it seems like we probably shouldn't go immediately to armed, right? So I guess we go to canceled. If the key is in the armed position when it boots up, then I think we should start in canceled instead of neutral. So back up here, when we set it to neutral, let's actually go if, but we don't actually have what we need yet. Let's move this down. So red button dot value, not red button dot value. If the red button is down or EA value is down, i.e. the key is turned to the right, or if that's not down, or is, yeah, no, or, so we definitely want ors, or if not, key B. And let's make this nicer. Okay, so if any of those things are true, given the fact that we have the knots here, if any of these are low, that means that their switch is engaged. Either the red button is pressed, the key is in the right position, or the key is in the left position. If any of that stuff is true, then we actually want to go to canceled instead of neutral. We start in canceled. Right now we're in neutral. I'm gonna push that, which is gonna take us to canceled, and then I'm gonna rerun the code. So the device is gonna reboot. And when it reboots, the red button is down, therefore we go directly to state canceled. We want to get out of canceled, we have to release the red button, we have to go to reset, which is left, we have to go back to neutral. Now we're in neutral, you can go to armed, signal 3 for armed. If we go back, we go to canceled. Once we're in canceled, we make sure the red button is up. In this case, the red button is already up, so we go back to the left for reset, back to the middle for neutral, back to neutral. There we go. I think we've got pretty much what I want. Are there any cases we didn't cover? I don't think so. So I had not built the idea of states in before, so I don't really have anything checking state like signal S. And so what we want is we're going to want to change our logic some. I actually want to change some other stuff as well. I'm just going to get rid of all of these for now. So another thing I want to do is I want to build in a delay. I want to make it so if you're in armed mode, keys to the right, and you press the green button, I want that to start the process but I also want there to be time to where if you press the red button afterwards within a certain amount of time, or if you turn the key back, if you do either of those two things within a certain amount of time, then the rocket will not actually launch. I want like a delay. So you press the green button and then you get maybe 10 seconds. And during that 10 seconds, if you press the stop button or you turn the key back, then the rocket will not end up launching. And I could do that in the Python code. But I think I'm actually going to do that bit on the Factorio side. And the way that I'm going to do it is just by adding a belt. Adding a belt that is just going to bring a thing to here, and the time it takes for it to travel along the belt is going to be the delay time. This is not the only way to do this. It's probably not even the best way to do this. This is the way that I am going to do it, though. Maybe I'll change my mind. We'll see. Should have been farther away from this. Ah. Okay. I don't know if that was, it probably was not quite 10 seconds, but it's good enough, I think. We can also tweak it later on to change the behavior further if we want. And I think I'm going to move the combinator. The way this works right now is actually really primitive. It's just looking for the only constant combinator. So you could not actually use this in the midst of a larger factory yet. I hope to have a way eventually, though, where you could actually... like, the best way would be to make a mod that introduces a copy of the constant combinator that is the microcontroller combinator that allows you to send these signals over, but I don't know if I have the capabilities to do all of that. We shall see. Right now, though, it works good enough by just having this. And so we're going to need a couple of different things. Cider combinators. I'm not used to the controls. So if S is 2, that means that we are in the canceled state. And if we're in the canceled state, I want to output red at value 1. Let's see if that works. Oh, it did input count. Really, I want 1 instead. And then yeah, there we go. Output is outputting 1. So I think we need another one of these still. Let's get a stack of those and a stack of those. So if state is 3, that means we are armed. Whoops. State is 3, that means we're armed. We want to output green. Right now state is 2 because we're canceled. We reset by going to the left, back to the right. Now we're in neutral. So at this point, nothing comes out. For neutral, I think we should maybe make it yellow. I don't know for sure if I'll need all of these signals, but one doesn't seem like it's out. Oh. There we go. Now we'll have signals coming out for red, green, yellow based on our state. The other thing we need is the rocket, which is the green button. So like we need to know when the green button was pressed. So both of these two should have a condition that says only if the state is armed. If the state becomes unarmed, anything other than armed, then these two should not be allowed to move. That means they won't grab from here. They also won't grab from here to put back. Do we have this loop back around? This should probably loop back around. I kind of cramped the space a bit. I will, I guess you can I delete this or something? Oh. There we go. So if it doesn't get grabbed by this, then it's just going to come all the way back around. This one's going to grab it, put it back in the box. And we actually want on all three of these, we want them to only work if it's armed and if the green button was pressed. Which in our case right now, the way that works is... Is it actually set up? If the green button is pressed... we need to add the logic there, actually, because when we're in the armed state, that's when we'll press the green button. We actually want it to be a bit different than this. If it's armed... Should we have one more state for firing? I don't know. For now, let's not. Let's just say it's armed and we send the signal to fire. We can always get back out of armed if we want to cancel it, as long as we do it soon enough. So in this case, we are going to send... we might as well make it 2, and we're going to send rocket silo as 1. If the green button gets pressed while the state is armed, then we send rocket silo value 1 in index 2. Right now it's neutral. Now it's armed. Got green for armed. And then do we want to just use... So first of all, I think we can just tie all these together. And then this value can go to here, and here, and here. Oh, no it can't though. No it can't. We need actually another thing. Arithmetic combinator. This one is going to say and if green and rocket, then output, and this is where before I had it output fish. Oh, I don't know where I found fish. Fish. And then I guess we'll need to pass through from here to here as well, because that will allow rocket silo to come through. Technically, we're still passing the signal up as well. Suppose we could make another one of these that would get rid of signal. I don't know if it matters, or state. But right now it's armed. I'm going to press the green button, which puts rocket silo there, which means Both of these are true, which means this outputs fish. And then when that outputs fish, that's when we want all three of these to be active. Those will only move when fish is greater than 0. This one, though, is unrestricted, so it'll always reset the thing back into the box. Trying to think if I want to like put more than one thing in here. So right now it is armed and has been launched. Let's test the canceling. So oh, that's as small as we can go. Okay. If we go red, that should make it canceled. I guess we should turn off rocket silo also. Anytime when we go to state canceled. Thank you. I wonder how do we clear it? I mean, I could set it to 0 and that would work, but it'd be kind of nice to clear it. Send it blank. This time it did come through as one thing. Hmm. This time it came through as two things, but the new line is in it. And it didn't clear it. So how do we clear a signal? It's gotta be set signal somehow. Hmm. So I have this one, read signal. Signal 0, signal name. Let's say if the first digit is an R, we're gonna go read signal whichever number they asked. Read signal 2. Not execute. And about a parentheses expected near S. Stuff I don't know. Is that actually on line 4? 4? Hmm. Well, it used to work. See what command it thinks it's sending. Well, for one thing, it's getting kind of both. I see. There we go. Okay, Rocket Silo 1 is currently the value. So if I clear it, though, and let that run again, where having this on two sides was kind of nice. Not execute command. Attempt to index field signal, which is a nil value. So we tried to get signal from here, and instead we got nil. So maybe if we go set signal nil? Set signal index and then just nil for this entire thing? So if 0 is clear, C for clear, then clear signal command parts 1, so the index. Probably don't actually need this to print. The index into there. Okay. We send clear, it should call clear. Let's rerun serial. Clear, index 2. New line. Need to maybe make it strip the new line back out so that I don't need the comma there. That would be kind of nice. But before I run this, I'm actually going to go back and I'm going to get it so that Rocket Silo is outputted there. So right now we're in state 2, which is canceled. Put the red button up, key back to reset, key back to neutral. Okay, we're in neutral. Go to armed. I actually have a thing that this is going to grab. No, not right now. Although, should we try? Let's try. I'm going to try to cancel it. I'm going to put this in here. We're currently armed. When we press the green button, that means that this one will grab the satellite out. We then have until the satellite gets all the way to here to cancel. And if we do, then it should just wrap back around and reset. So, green button. Okay, it's moving. I'm gonna go cancel. Nice, skips right on past. Now it's back in there. And now we have Rocket Silo on 1. So I want to test the clear, well, Rocket Silo on 2, because, again, the indexes are wrong. So we clear 2. When this code runs... Ooh. Clear signal missing. Oh, client. Wait. Clear signal. We need to pass the client also, yeah. We need to rerun this. And then we actually probably need to rerun this one as well. It's the easiest way. Nice. Okay, so we cleared out the rocket silo. We're currently in the canceled state, which is because some doofus left the key in armed, and that's what we told it to do. So if we want to get back to neutral, oh, also the red button is down, so we would have been in canceled anyway. Do that to get ourselves back to neutral, though. Okay, so this is coming together. This is pretty much doing what I want. Yeah. No. Okay. Got some weird crypto spam on Discord there. I see. Also got notification from, I see, from the server where the people found me. I did not have the live chat up at all, so I apologize, folks, but I hadn't seen anybody. But on that note, if you're all still around, Paul, Johnny, how's it going? New line and return feed a new line. Return feed a new line is maybe what I need to put on the end. This was a while ago, I know. How's it going, DJ Devin, if you're still around? Isn't US letter paper? That's true. I have heard it called that as well. A4. On the right side below the indent property, you can see lists. Oh, back into PowerPoint. I missed it back then, but cancel equals scram, armed, disarmed, launch, scram modes. Okay, yeah, sorry folks, I didn't have the didn't actually have my Discord open until now. YouTube has paused the music. Let's get that rolling again. There we go. So at this point, if we actually were to not cancel it, we should be able to launch. So we're in neutral right now. Go to armed. Go to launch. Okay, there it goes. I'm gonna let it go this time. There it goes. So we want to clear rocket silo. We want to clear rocket silo pretty much anytime. I want to clear rocket silo a lot, actually. So when we first launch CodePy, when it first boots up, we want to clear rocket silo if it exists. So clear that. I think we could get by without the sleep now because of the new line. Maybe I can do it without. It's ended up still with that in the one. I'm gonna do it just like that for now. Did it actually work? It did work. We do read line, if line. What if we go line equals line? How's it going, Air Duck? Is this giving me everything but the last? Nope, wrong way. Oh, there we go. Everything but the last. Yeah. That should get rid of the new line, which we know will be a new line. So then theoretically we shouldn't need the comma anymore. We should be able to just go like new line. Should probably have it on all of these though. We run the serial interface. Oh, that saved my CircuitPy. Yeah, there we go. And we went straight to canceled because I left the key turned. Let's get back to neutral. So one thing is, whoa, right now we would need to put another thing in here. There's not actually another thing. Somehow I'd like it to just grab once. It'd be nice if we could just leave a whole stack of stuff in this box, and then it would grab one at a time, put it on the belt, and do the rest of the stuff. I don't know how to do that, though. We'd have to reset the signals back to off. So maybe we could watch the contents of this box, and when it gets a thing in it, whenever this gets a thing in it, then we make one more box. And whenever we see that this one has a thing in it, then we take one from this one and move it to here. Because if this one has a thing in it, that means that we grabbed it from here and it came through. There an anything? Anything is greater than 0. So now we would basically reload this box with 1. But the problem then is that once it gets to here, then this will grab 1 back, and this will still be on fish. This will still have fish because all of the stuff will still be true. We also need to basically... We need to basically reset... We need to reset the state back to neutral, I guess. I feel like this is not that complicated, but I'm not actually seeing the solution right now. If we had one more condition on this one... Can you attach wires to the... No. So the thing, we kind of need to write back to the constant combinator maybe, because we need to like reset it to be in a different mode. How do we get it into another mode? Okay. Okay. How about we only move it from here to here when it becomes armed? So when it's in the neutral state, there will not even be anything in this box. When it becomes armed, it gets moved from this box to this box. When it gets fired, the green button, then it gets moved from that box to the belt, does its delay timer. If it's still running by the time it gets here, then it goes. If not, then it resets. So we should actually have it reset to this one. So now, if we could only do this one. So I think we don't need this anymore. Oh, okay, well that wasn't very smart. We basically want this to pulse once when it becomes armed. So there's a couple of ways we could do this. In the CircuitPython code, we could have it set another signal and then like set it high for one frame and then back to low the next frame. We should be able to make a rising edge detector, something. Should be able to do this inside Factorio. Rising edge detector. Arithmetic combinator signal plus 0 output B. Saves the value from the last pick. Decider combinator signal not equals B equals pulse. So arithmetic combinator. I'm going to put this one going this way. And then a decider combinator after that. And in the arithmetic, it was signal plus 0. Our signal that we care about is becoming armed. We want to hook this up actually not here. We actually want to hook this up here. So in the armed state, we're going to get green. Green plus 0? Green plus 0. And then output it as something else. It chose B. I'm going to output it as grabby arm. Because ultimately I want it to be a grabby arm moving from one box to the other. Signal plus 0, output to B, and then on the decider combinator we say signal not equals B. So grabby arm. Oh, no. Green. Green. Not equals grabby arm. Then we output, let's say grabby arm. And so let's test this here. Grabby arm greater than 0. Let's put some stuff in here. We need to wire the output of this to the input of that. So I think now when this starts outputting green, if I understand right, this should pulse at the very far left side of this. It should pulse one tick of grabby arm at value 1, which should cause this grabby arm to grab one thing and move it. Well, to grab however many things it can. But we actually want it to be 1. Okay, so right now we are neutral. So we want to check if when we get armed, if this grabs one thing. So from neutral, we want to go to armed. That does not appear to have worked. Green plus 0, output to inserter. Right now green is 1. 1 plus 0 should be outputting 1 grabby arm, shouldn't it? We are not actually. Combinator now looks like this. I feel like I'm missing something. So in this one, we have a condition. Their condition is Steam less than 10K. If that's true, then it outputs Z. This one is an arithmetic XOR. Does XOR do? Pairs 2 input bits, generates 1 output bit. If the bits are the same, the result is 0. If the bits are different, the result is 1. So specifically, if they're the same, that means they're both 1, which means we output 0 because they're both the same. That outputs Y. And then this says, but it would output Y 0. I'm more lost than when I started. The first one seemed easy enough, but They're saying if A is greater than 1, then output on A, and then another decider is if A is less than 1, then output on A. Wire the inputs to both of the two decider combinators. So that would be green for us. We'd be like green greater than 1, green less than 1. Input would go to both. Wire the output of D2 back to the input of D1. The green wire. Wire the output of D1, whatever you want to pulse. Input goes to both. I'm going to use opposite colors since most of my circuit's green instead of red. I don't think it matters. So if green signal, so if we just changed to armed, we output grabby arm. Doesn't seem like it's outputting. Maybe it needs a pull to... No? If green signal is greater than 1, I should absolutely... Oh, it's outputting, actually. Shoot. Okay, I see. I wonder if... Oh, man. I wonder if the old one actually worked. I think we wired it to the wrong thing. It would have been fish instead of green. Signal plus 0. We're going to try one more this way. Then I'll go back to the other way if this doesn't work. Probably going to wrap it up before too long as well. So we would actually want to output from... Technically from this one, which outputs the green state. Green state plus 0, output grabby arm. So that is currently outputting. Decider combinator signal not equals B. So signal is green. B is grabby arm. Then we want to output grabby arm again. It's 1. So this one gets fed into here. But the input of this one also, we want to match up with the input of this one. So this has input of green and grabby arm. It currently has no output. Say if grabby arm greater than 0. We'll try that in a minute. I have to run to the restroom though, so I'll be back. Sorry. Okay. Fix the carpet. Okay, so if stuff works, then it should output one pulse. Would make it grab one thing. And that's when we go to the armed state. We are actually currently in the armed state. But now we're detecting the rising edge, so we want to get back out. That's going to take us to canceled. Canceled, of course, we can reset going left and then back to neutral. Then armed. Didn't work. Oh, this is empty. We don't know if it worked. Okay. Interesting. Okay, so it went... That's not right. So this is a change detector, not a rising edge detector. Yeah. Okay. So that's really close. So maybe this will be only a rising edge detector now instead of just a change detector. But what state are we in? We're in canceled. At an and, yeah. think that's what we ended up with. We're in neutral, armed. It didn't work. I don't really know why it's not working though. Although it is weird, this is constant output now. I think maybe we can't use grabby arm. I think maybe we can't use grabby arm. Okay, yeah, I think maybe using grabby arm for the intermediary step was actually breaking it. We're currently armed. Now we're canceled. Now we're neutral. Now we're armed. Grabbed exactly one thing. Now we're canceled. It did not grab anything else. Okay, so when we go to armed, this will grab one thing. Now we put that there. Take this from this one. Set that to grabby arm greater than 0. We move all of these things back because it got a little ahead of itself there. Oops. Okay, so we're canceled. Reset. Armed. Launch. Gonna launch the wood first. I don't think launching wood does anything, but we've done it. Okay. And now we can't load another thing until we go to the armed state. Only way we can get back to the armed state is go through cancel, back to neutral, and then arm it. Okay, I'm gonna do one more trial run after this is done making the next rocket. Take it a second to make the rocket here. I'm gonna do one more trial run where I'm gonna cancel it while we're in the waiting period here. As long as that works, then I'm gonna call this good for right now, and I think head off and do some other stuff. But this is basically what I was envisioning. I may still enhance it a bit. I do still want to make a document for it, because again, I think it'll be kind of funny to have an instruction document that looks like a industrial manual. And then I'll probably like record a video that talks about it a bit. Ah. Okay. Rocket's ready. It's pretty neat to see it come together and start working. Yeah, thank you. I appreciate that. I've had this idea in my head for a while because, like, I bought this thing. I don't even know exactly. I'd have to go back and look. I bought this thing a while ago, and the intention was always to do this. And I had like an itsy bitsy that was set aside that I was gonna put inside here for a while. But I never figured out the right way to like get the signal from this thing into Factorio until recently. By now I got Pico W's, and I figured I'd go ahead and just put a Pico W in here, because also we could change the code on this to do like non-Factorio stuff. We could have this send get requests or do whatever we want with these different inputs. Maybe we'll make something else. Maybe we'll make it in, like, you could do a get button or something, like where you have to turn the key and then press green to commit or something. I don't know. Could find some interesting stuff with it, but okay, so next rocket's ready. We are currently neutral. One thing is we do still have rocket silo 1. Right, we want to clear rocket silo actually whenever we, honestly, when we change any state. Certainly when we go to neutral. Realistically though, we should just do it when we change to any state that's really any state. This is the one place where we don't want to do it. Pretty much everywhere else, though. I mean, I guess we don't need to do it when we change to armed, but so we'll make sure we clear out rocket silo. Okay, so now we're neutral and we don't have rocket silo. And you know, the other thing I should test, which I don't think I've done, is we should make sure that pressing the green button doesn't work if it's not armed. Nice, which it doesn't. So we want to go to armed, load one thing, press the green button, and then I'm actually going to cancel it. I'm going to cancel it with the key. Right there, we cancel it. Doesn't get grabbed. Goes back around and resets. Sweet. Neutral. Armed. Fire in the hole. Hooray. There we go. All right, that is it for now. This is, again, something I've been kicking around for a while in my head, so I'm happy to finally be able to have it work and even do all the behavior and stuff. So I want to build that little nifty document for it and then record a video about it, and probably about it for this project. That's the main thing I wanted to do. So thanks for hanging out, folks. Appreciate the help in the chat. Sorry again, I didn't notice the chat there for a little while, but we found it there eventually. Appreciate y'all watching nonetheless, and offering out helps and tips and interactions in the chat there. Put all that junk in orbit. Yep. Yeah, this was a fun one to figure out. Like interfacing with different stuff is always a fun challenge, and I got really into this game for a while. So I don't play it as much as I did, but I still like it, and I still like tinkering with it. It's a nice medium to tinker with. All right, thanks for watching, everybody. I will be back probably sometime tomorrow, working on CircuitPython stuff. Beyond that, I'll be back on Friday for deep dive. And next Saturday, I think, for the morning stream. So I hope everybody has a good rest of your weekend, and I will catch you next time. Thanks for hanging out.